Hello everyone, my name is Gina Kim. I'm the instructor for this course. Welcome to the Artificial Intelligence course. In this video, I'm gonna walk you through what this course will be about.
So in this course, we'll learn about a variety of class of AI problems, which consist of three big parts. So the first part will be search problems. And the second part would be when the conditions that we assume about the search problems are relaxed. Things that happens with the probability, we'll talk about those, how to handle those. Talk about MDP and Bayes nets and some of the algorithm called reinforcement learning. And the last part we'll talk about learning agent, which means that the model learns from the data and then learn how to act based on its experience. So we'll talk about some of the machine learning models, and then we'll also talk about briefly about deep learning and its applications. In each categories, we'll talk about how to formulate the problem and what's the properties of the problem, and that leads to which algorithm is suitable. So as a consequence, we'll talk about problem solving techniques, in other words, algorithms. And we will also talk about how those algorithms perform. And we'll also talk about how to improve those algorithms using various methods and frameworks. And also, importantly, we'll do various of assignments and activities to implement these ideas into codes and have a hands-on experiences. Okay, so this leads to the idea that we should include the codes in our algorithm. It's called uniform cost search, which expands the cheapest node first. See how it works. So you start from the start state and call the successor function to find the fringes. And then now I find that the node P has the least cost. So I'm going to open that one. And then see all my fringes, new fringes, and then find the D is the least cost. So I open that one. And then now I find the B is the next one, and then I find which one is the cheapest. Okay, so E is the cheapest, so I'm gonna open that one, and these white circles are fringes, and now I see A is cheapest among these, and then what else? I see R is the cheapest. Let's continue talking about reinforcement learning. So the biggest difference between the reinforcement learning setting and the MDP is that a model for the environment dynamics is not known, as opposed to in MDP, we knew everything, the transition dynamics and the reward and so on. But here, in the reinforcement learning setting, agent must act to figure out what word it will get or how the environment acts. So initially, this cheetah robot is trying to learn how to run. So because it doesn't know how things work, it will just try and get rewarded when it makes forward progress. And by now you can see it's started running faster. So let's talk about why we learn deep learning. So deep learning has a wide application recently. So for example, self-driving cars have different sensors and as well as the camera. So using deep learning, we can fuse this information together and then do the computer vision. So before there was deep learning, people used to do this kind of approach. So you can see some cameras and other sensors such as ultrasound or LiDARs. Oftentimes it's super expensive to make because of the equipment and also expensive computations. So instead, nowadays people use this approach. So here we have one or two cameras to recognize the objects, and using the deep learning algorithm, it can find out which objects are the cars and the pedestrians and something else. So okay, that's a brief overview of this course, and we'll start discussing about what's the intelligent agent and what the search problem is. All right, see you next time.